7.3 Special Products of Polynomials. Okay, so here I've got x plus the quantity x plus 3 squared. We're going to simplify. So this represents one of the most common algebra mistakes, I think, of all time. So a lot of times this is going to be incorrect, okay? So this is going to be what not to do. But people will just say, oh, I'll just square the x, and then I'll square the 3, and I'm done. But that is incorrect. You can't just do that, because this really means x plus 3 times itself. Okay? And when we're multiplying a binomial times another binomial, you can't just square the terms. You're going to have to either distribute the x, then distribute the 3, or I'm going to FOIL. When I have two binomials, I like to FOIL. So I'm going to do first, outer, inner, last. Okay, so first I've got x times x. Those are the pieces in front. That's x squared. Outer is x times 3, which is 3x. Inner, the ones on the inside, 3 times x. And last, the pieces at the end, 3 times 3 is 9. And then I add up all of those pieces. So I am going to get an x squared and a 9 in my answer, but I also have this stuff in the middle, which is super important. So this is going to be x squared plus 6x plus 9. Okay, and that is my solution. Okay. Now this is when we're squaring binomials, there's a pattern that occurs. Now honestly, when I square binomials, I just FOIL it out. Then you don't really need to memorize the pattern, but there is a pattern that's worth knowing. Okay, so here is the pattern when you're squaring binomials. So this is when in your binomial you have something plus something else. Okay, so our a and our b are just generic, and it's going to follow this pattern. So let's say in this, when we're doing this example, I mean this is the same problem, so it should come out to this. But let's try it using this pattern. So the x is going to be my a, and the 3 is going to be the b. Let's substitute in. Okay, so I'm going to put an x in in that a position. Then I have 2 times a times b. Well, a is x, and b is 3. And then I have the b squared, and the b was 3. And then so when we simplify this, well, 2x times 3, that's going to be 6x. And 3 squared is 9. So you can see we got the same result as when we FOILed it out. So that pattern is always going to work when you have a binomial that you're squaring in that pattern. So it has to be something plus something else, like this example down here. Okay, when you're subtracting the second term from the first one, it's a slightly different pattern, but it's very similar. So we're going to have a squared minus 2ab plus b squared. Okay, so here my a is x and my b is going to be positive 3. Okay, so this is the a and this is the b. The negative just tells me that I'm using this formula as opposed to that one. Okay, so I'm putting in an x here for my a, an x there for my other a, and the other 2 slots are going to be the b's, so those are 3's. Okay, so then when we simplify this, let's see, negative 2x times 3 would be negative 6x plus 9, and there we go. Okay, and you could try just if you multiplied out on this one x minus 3 times x minus 3 and FOILed it, you're going to get that same result. Okay, first would be x squared, outer and inner are both negative 3x, that gives you the negative 6x, and last negative 3 times negative 3 is positive 9. So it works either way. Okay, all right, but let's try it with the pattern. Okay, so here's an a and a b. Since we're adding these two, I'm using this pattern that's right above. I'm just putting blank parentheses anywhere there's an a or a b. So these are the a's, and that's going to be x here. And my b's are the 5, so that goes there and there. Okay, so this is just x squared, and then I'm multiplying all this together. That would be 2x times 5 is 10x. And 5 times 5 squared is 25. There we go. Okay. And this one, since we're subtracting, these are the a and b, but the subtraction gives me that different pattern. I just find it's so easy to get these two patterns mixed up. I like to just FOIL. But the book likes to do it this way, so that's what I'm going to stick with. So those are my A's, and then there's the B's. And then I simplify. Okay, in the middle, that's going to be negative 2x times 6. That's negative 12x. And then 6 squared is 36. And there we go. Okay. Okay, so let's try some where the A and the B are a little bit more complicated. So here we're adding again. This is my A and this is my B. Okay, so the pattern from above, A squared plus 2AB plus B squared. So in those first two slots, I'm going to put the quantity 2x. Okay, and now it becomes really important that you use parentheses here. So a lot of times I'll see people have 2x squared without parentheses, but that's really very different than 2x, the quantity 2x squared, because we're doing 2x times itself. 2x times 2x is actually 4x squared when you write this without parentheses. Okay, and then I've got 3's there. So really important that you use parentheses when you set that up, and hopefully then you'll remember, oh, this means 2x times 2x, that's 4x squared. In other words, you're squaring the 2 and the x. Okay. Then here I do the multiplication. Let's see, that would be 4x times 3 is 12x, and then 3 squared is 9. Okay. All right, this one, there's my A, there's my B, and the pattern is going to be A squared minus 2AB plus B squared. Okay, the A is going to be 3x, the B is 4, and then I got to think that's going to be 3x times 3x, that would be 9x squared. Okay, here I've got negative 6x times 4, that's negative 24x, and then 4 squared is 16. On the next page, we have a different pattern, and in my opinion, this pattern is much more important than the ones on the first page, because we're going to use this pattern a lot when we are factoring later on. It's going to come in very handy. Okay, so these problems we can still just FOIL. It'll definitely work to FOIL. But when you have binomials like this, where you have x plus 10 and x minus 10, or a plus b times a minus b, it's always going to work with this pattern. Okay, it's going to be a squared minus b squared. So let's set this up. So here my A is going to be x, right? And the B is going to be 10. So that means I just put an x here and a 10 here, and then simplify this. So x squared, and 10 times 10 is 100, so x squared minus 100. Okay. All right, so let's try it out on these other two problems as well. So a squared minus b squared. So the a here is 2x, and the b is 1, positive 1. Okay, so really important to use parentheses, because you got to think 2x times 2x is 4x squared. Okay, and then 1 times 1 is 1. So 4x squared minus 1. All right, one more. A squared minus b squared. So my a is x, and the b is the quantity 3y. All right, so that gives me x squared. 3y times 3y would be 9y squared, not 3y squared, right? So there is my solution. And that's the end of the section. Pretty short section. See you next time.